Chapter 4, Section 3 is about writing and evaluating functions. And the first thing we're going to do is just write these using functions. First of all, Tammy charges $5 per hour for babysitting, and we want to write a relation there. So that's just going to be y equals 5x. $5 an hour, y equals 5x. These next ones we're going to go a little bit out of order. And let's start, we're going to save these two for last. Let's start out here with number 2. We have this chart, 1, -2, 2, -1, 3, 0, 4, 1. And we want to write a relation between those, see how they relate to each other. And what we need to do first of all is we need to find the changes, how much the y's are changing. It starts at -2, it goes down to -1, it goes to 0, it goes to 1. Our y's are increasing by 1 each time, so it's becoming a +1, going up by 1. So that's the number that's going to go in front of our x. It's going to become y equals 1x. And you can just write it as y equals x if you want. And I got that number right there from how much the x's, or how much the y's are changing. They're going up by 1. And now what we need to do is we need to put one of these numbers in here, and I'm going to look at the 3 because I don't want to have to deal with negatives. Let's put the 3 in here for this x. If I put the 3 in here, I would have 3, but this table tells me at 3 I actually want an answer of 0. So what do I have to add or subtract to that 3 to get a 0? You have to subtract 3. So our equation then would be y equals x minus 3. This came from the change in our y's, and then we put one of these numbers in and see what we have to add or subtract to get to that number. Let's look at number 6 next, and again we're a little out of order. Start by looking at our y's and how much are these changing each time. From 1 to 3, 3 to 5, 5 to 7. How much are those changing each time? 2. So we're going to have y equals 2x. And we have a 0 in this chart, which is a nice one. If you have a 0 in the chart, you can actually just add that number. So this would become y equals 2x plus 1. Number 8 here is a typo. This is supposed to be a -2. So write a negative in front of that 2. And let's first of all look at how much our y's are changing. We go from 4 to 6 to 8. How much are the y's changing? They're going up by 2. So this is going to be y equals 2x. And if we have a 0, if we put the 0 in here, we would get 0. But we want 8. What do we have to add to that to get 8? If you have 0, what do you have to add to get 8? 8. So that would be y equals 2x plus 8. I'm going to add 2 more examples in here because I think we need a little more practice. So write numbers 10 and 11 down here with me. So we will have 2, 7, 3, 9, 5, 11, and 6, 13. How much are our x, or how much are the y's changing? 2. So it becomes y equals 2x. And then, alright, I didn't do my equation right. Hang on, I have to change these numbers.
That means the 2x is going to change too.
Okay, hang on, let me come up with a better example. So let's do 2, 13. 318, 423. Let's try this one. How much are your x's changing? From 13 to 18 to 23. How much are they going up?
5.
13 to 18 is 5. So it's going to be y equals 5x. And then let's put this number in. If we put the 2 in here, 5 times 2 is 10. But we didn't want a 10, we wanted a 13. So what do we have to add here? Plus 3. And if you decided you wanted to use the 3 instead, 5 times 3 is 15. And if you needed an 18, you would add 3. All right, there's one more example. Number 9, Billy makes $8 an hour working at Subway. We have to write an equation. That's going to be y equals 8x. Number 5 and 6 that we skipped, let's take a look at these two. Number 5, we have 1, 1, 25, 5, 110. And there is a relationship between these. This is not linear. And let me add a couple more examples in here that might help you out. 36, 6, 49, 7, 64, 8. Does anybody see a relationship between those numbers? And this is one, there's no quick trick for it. You just need to learn to recognize it. Austin? Close. We're the other way around. The square root. Okay? So this would be y equals the square root of x. Those are, we started out with the perfect squares, and then we took the square root. And number 7, 1, 1, 2, 8, 327. Your next numbers would be 4, 64, and 5, 125. Does anybody recognize this one? It's cubed. Y equals x cubed. And that one again, you just need to learn to recognize the squares and cubes. And then these last two examples, number 3, we have 1, 3, 2, 6, 3, 9, 4, 12. Looking at your x's, those are increasing by 3 each time. So it's going to be y equals 3x. And then when you put one of those numbers in, you put 2 in here, you get 6 back. If you put 3 in here, you get 9. So this already is in the form. You don't have to add 0. It's just y equals 3x. And when you look at number 4, I say this one towards the end, look at your x values in that chart. And what do you notice about those x values in that chart? Anything? What's that? Okay, they go up by 5s. They don't go up by 1. So there are actually 5 numbers here. We skipped over the 6, 7, 8, and 9. And the y's here go up by 1, but it actually goes up by 1 for every 5 numbers. So if we had the 6, 7, 8, and 9 in the chart, we would have 6, 1 and 1/5, 7, 1 and 2/5, 8, 1 and 3/5, 9, 1 and 4/5, and then 10 is 1 and 5/5, which is the same as 2. So this one is actually increasing by 1/5, and that will be our equation, y equals 1/5 x. And I do not think you have one like that on your homework assignment. And the last thing on this front page, your independent value is your domain value, which is x. and your dependent value is your range value, which is your y. So your independent is your domain, which is your x. Your dependent is your range, which is your y.